Welcome back. In today's lesson, we're going to talk about a very important software design concept called modular code. If you have ever looked at a large code base and felt overwhelmed by hundreds of lines of code, then this topic is for you. Many beginners focus only on making their code work. While that is important, professional developers also think about how easy the code will be to understand, maintain, test, and improve in the future. This is where modular code becomes extremely valuable. So what exactly is modular code? Modular code means breaking a large program into smaller, independent pieces called modules. Each module has a specific responsibility and performs a specific task. Think about building a house. You do not ask one worker to do everything. Different people handle electrical work, plumbing, painting, and construction. Each person focuses on a specific area. Software works in a similar way. Instead of putting everything into one giant file, we divide the program into smaller parts that handle different responsibilities. Let's understand this with a simple example. Imagine you are building an online shopping application. The application needs user registration, product management, payment processing, and order tracking. A beginner might write all the code in one large file. At first, it may seem easier, but as features increase, the file becomes bigger and harder to manage. A modular approach would separate the application into different modules. One module handles users, another manages products, another processes payments, another handles orders. Now each module has a clear purpose. When you need to update the payment system, you know exactly where to look. This brings us to the first major benefit of modular code, which is readability. When code is organized into small pieces, it becomes easier to understand. Instead of reading thousands of lines, you can focus on a specific module. This saves time and reduces confusion. The second benefit is maintainability. Software is rarely finished after the first version. Bugs appear, features change, customer requirements evolve. Imagine that 6 months after building your shopping application, you need to add a new payment gateway. If your payment logic is isolated inside a payment module, the change becomes much easier. You do not have to search through unrelated code. The third benefit is reusability. Suppose you create a login module for one project. Later, you start another project that also requires user authentication. Because the login functionality is already organized as a separate module, you may be able to reuse much of the code. This saves development time and reduces duplicated effort. Let's look at another practical example. Imagine you are creating a calculator application. A beginner might write addition, subtraction, multiplication, user input, and output display all inside one large function. A modular design would separate these responsibilities. One function handles addition, another handles subtraction, another manages user input, another displays results. If a bug appears in multiplication, you can directly inspect the multiplication function instead of searching through the entire application. Here is a third example. Suppose you are developing a student management system. You may create one module for student information, another for attendance tracking, another for exam results, and another for report generation. Each module focuses on one responsibility. This makes the system easier to understand and extend in the future. Now let's discuss the mindset behind modular code. Good programmers do not immediately start writing code. First, they think about the problem. They identify the different responsibilities involved. A useful question to ask is, can this part of the program work independently from the others? If the answer is yes, it may deserve its own module. This problem-solving approach helps you design cleaner software from the beginning. Unfortunately, beginners often make several mistakes. One common mistake is creating giant functions that do many different things. For example, a single function might read user input, perform calculations, save data to a database, and display results. This makes the function difficult to understand and modify. Another mistake is copying and pasting code everywhere. When the same logic appears in multiple places, fixing bugs becomes harder because every copy must be updated. A third mistake is choosing vague names, such as process data or handle everything. Clear names help developers understand the purpose of a module immediately. Now let's discuss some practical tips you can start using today. Whenever you write a function, ask yourself whether it has only one responsibility. If it does too many things, consider splitting it into smaller functions. Use meaningful names that clearly describe what a module does. Keep functions relatively short when possible. Smaller functions are usually easier to read and test. Group related functionality together. For example, keep all user-related operations in one place and all payment-related operations in another. Do not worry about creating a perfect design on your first attempt. Even experienced developers improve their designs over time. The goal is continuous improvement. As projects grow, modular code becomes even more important. Teams often have many developers working on the same application. When the system is divided into modules, different developers can work on different areas without constantly interfering with each other. This improves productivity and reduces mistakes. Let's do a quick recap. Modular code means dividing a program into smaller parts that each have a specific responsibility. It improves readability because code is easier to understand. It improves maintainability because changes are easier to make. It improves reusability because modules can often be used in multiple projects. It supports better problem solving because developers learn to break large problems into smaller manageable pieces. Remember, writing software is not only about making code run. It is also about making code understandable, flexible, and easy to improve. The habit of thinking in modules is one of the most valuable skills you can develop as a programmer. Keep practicing, keep building projects, and whenever you face a large problem, try breaking it into smaller modules. Over time, you will notice that your programs become cleaner, your debugging becomes easier, and your confidence as a developer continues to grow. Thanks for listening, and I will see you in the next lesson.